So also go back to the so
Hello guys. Works. Okay, so this is the LP1 working group. It's going to start in a few minutes. If you want to follow BGPv4, you're in the wrong room. Oh, much better. Okay. And I recognize from the T-shirt that some of you are in the right room. If you don't have a green T-shirt, please leave the room immediately. Okay, no, that was a joke. Okay. With this, Alex, you will? Yes.
Yep. Okay, you want to try plugging this in? This way our dear presenters are going to be able to change. Okay, so I think that... Okay. So yeah. So hello everyone. As Pascal said, this is the LP1 working group. And this is an IETF meeting. So as in all IETF meetings, please do read the note well. So all the regular APR rules apply. So if you're aware of any APR, please do say so or don't talk about it here. So everything that you say is considered as an IETF contribution. Also everything that you write on Jabber or on the Meet Echo. And also please do read the code of conduct and all the BCPs that are listed on this note well, while you're participating here. So as a reminder, minutes are taken. We have so we have our minute takers. Thank you very much, Ivailo and Carles, for agreeing to do this. And thanks, Thomas, for the backup as a minute taker. And our Jabber scribe is Cedric for this meeting. Yes, please do sign the blue sheets when you see them circulate. So the minute taking takes place in the Etherpad. So you can go to the agenda, click on LP1, and then you can have this link. So this is the official link. It's also on the slides. Yes, for remote participation, you have Meet Echo and or Jabber, and you can have all the meeting materials, of course, already on the IETF website on the data tracker. Taking the minutes, Ivailo and Carles. And for the Jabber, it's Cedric. So today we have a pretty tight agenda because with the new timing, there are a maximum of 2-hour slots, and we're very happy to have this time. So we squeezed a little bit the different type of the different presentations that were in the agenda announced 2 weeks ago, because we wanted to spend a little bit more time on discussion on rechartering. So we will have the bulk of the time will be dedicated to the announcement, to the advancement in the relaunching of the IPUDP SHIC draft, and then we'll have some other presentations for Sigfox, LoRaWAN, IEEE, and then some other discussions on the rechartering. So do you have any adjustments that you would like to make to the agenda? No adjustments, so we can just move on. And go. I'm doing this very shortly so that we have more time for the real work here. So we have just as a little reminder, we have our status. We have our 2 charter items. The first one is done. We're working on the second one, and it is going to be the basis for the rechartering. We'll be talking about this later. So we've been very active in the past couple of IETFs and in between. So every time at every IETF for 5 times in a row, there is a hackathon, and we have quite a lot of interim meetings. We had 5 interim meetings since the last IETF. So please, if you are interested in following this work, you're very welcome to participate to these interim meetings. They are announced and accessible over the internet. Really very open discussions and very, very interesting things happening over there. A short reminder of what happens, and with this I'm going to pass the word to Dominic afterwards, is the main working document that we are focusing today is the SHIC for IPUDP. So we had a working group, we entered a working group last call in around the beginning of this year, and we had a lot of work done actually to clarifying a lot of aspects until the last IETF in July. And we actually really were very happy with the part of the compression. So we declared success on the compression part of the draft, but there were some ideas of how these things could be improved in the fragmentation part, and also make the document a little bit more readable. So the team really worked really hard during the summer, and thank you very much, guys, for the team for that work. And today we're very happy with the fragmentation part, and we'll be starting working group last call after this IETF. And with this, I'm going to pass the word to Dominic, so we can switch slides. So as Dominic goes up to the website, to present, yeah, we need to switch slides. Yeah, the camera is, yeah, it's over there, so okay, you can move a little bit forward. So this is how you can get all the website, all the slides. You can. It's not this one. Yeah.
Okay. It's a reading session.
Yes. So this is. Yeah. This is how you can get all the. Yes, and now you scroll down. Now you scroll down. Okay. Yeah, and now you need to click. Wow. We are good to go. Thank you.
Okay, good morning, everybody. Can you hear me? Yeah? Okay, I need to get to this, maybe better. Okay. So I'm here to report about the status of this draft. This is our agenda for this presentation. I'm going to go through the first items, and Laura is going to come to explain the details of the new fragmentation mode that was designed over the summer. For those of you who are new to this group, or maybe you come here for the first time, just to recap what I'm talking about, this draft is about 3 things, and they're all in one draft for historical reasons, but anyway. So there's a generic compression engine, a header compression engine that's here in the stack. There's a generic fragmentation protocol that's below it. And there's the application of compression for IPv6 and UDP headers. So how this generic stuff is used for this part. So these are the 3 deliverables, 3 things that you will find in this draft. The other things, which are how you apply all this generic stuff to a given LP1 technology, this is in separate drafts that are discussed in this session after my presentation or in other drafts. that are not going to be discussed today. Okay, what has happened since last meeting? So if you have been following the work on this draft, over the summer, we mostly focused on fragmentation. We believe compression is done. We had a working group last fall on that in the first half of this year. But we said we would rework the fragmentation part following some requests that came at Montreal and before. So over the summer, we designed a new ACONR mode over the interim meetings, and we also extensively rewrote this fragmentation section. Even though some things were not changed, they were simply rewritten because the text was has evolved incrementally over the years, and we wanted to have a fresh edit of the text. So if you have been following this draft before and you want to read -17, the 17th version, here's what you can expect to see changed and not changed in the draft. So in the abstract and introduction section, we've slightly improved the text, and we've introduced the notion of profile that was asked for by Pascal, rightfully, I believe. And we've removed the assumption that there's no out-of-order delivery, which was present right in the introduction before that, because we believe now that one of the modes, the fragmentation modes, does work with out-of-order delivery, so we removed that statement. The terminology section was updated according to Charlie's comments that if you don't use fragmentation, you shouldn't have to read about fragmentation terms and variables, etc. So the fragmentation terminology has been moved into the fragmentation section. So if you want to ignore fragmentation, it's easier. On the compression-decompression part, we just did some minor text improvements, no change in compression-decompression. We already went through last go. The major piece of work is the fragmentation reassembly section, which I'm going to talk about later, and Laurent is going to explain in details. Then we have this UDP IPv6 compression using the generic compression engine, which now mentions how you handle ECN bits if you have them. That was a request in Montreal, and improves the text a little bit. And then we updated the appendices mostly to reflect the changes in the fragmentation algorithm. Okay, on this weekend, right before the meeting, we had a hackathon. I just want to report a little bit on that. We started a new, fresh open source project for Czech called OpenCzech. We have brand new t-shirts to reflect that change. We agreed on a Python-free MicroPython based code and having a ground-up, redesign of the project. We had pieces of code here and there before in various languages, various repositories, various interfaces, and we are building a new project and got it started with the help of these guys and other guys that are not on the picture. What we got out of that is, of course, is the setup of this project, new pieces of code, but also a thorough reading of the draft, which led to a better common understanding on how this works. Feedback also from implementers. It spotted one shortcoming of the draft, and also more work items for the working group to be discussed in the rechartering part. Okay, so this is something we have to go to every time, ticket status. So bear with me. Since Montreal, we've opened 2 new tickets that are now closed. Ticket 23 was something related to the description of the MIG computation, and since we totally rewrote that section, the comment is no longer valid, so it's closed. And ticket 20, oops, okay, numbering mistake here. That should be something else, like 32. And anyway, one of the tickets is about optional MIG, and in -17 we've decided that MIC is mandatory in this specification, even though we made every effort possible that some other SDOs can reuse this generic engine, generic mechanism without MIC if they want to. And I understand Juan Carlos just told me this is a question he wants to discuss again. So we can discuss it. What's coming up next? So we're going to implement the changes resulting from the hackathon implementation. We're going, I understand, to launch a working group last call on the fragmentation section. I understand Charlie already has a review in progress. And we have this implementation in progress, as I showed you. In 2 weeks, we're going to have a presentation of the fragmentation modes, especially the new mode to the lower alliance. So people are looking at the work we're doing. It's good for us to know that this is useful even outside of this room. Okay, so now moving to the meat of the presentation, the restructuring of the fragmentation section. So if you have read this before in the -16 draft, what you can expect from reading -17 is a totally new structure of the section 8. And it's been laid out such that there are description of the tools you can use to do fragmentation. The tools are messages that you exchange back and forth, carrying data, carrying acknowledgements, carrying aborts, etc. The notions that you use to do the fragmentation, which are tiles, which are pieces of data, windows, which are bunches of tiles manipulated together, bitmaps, which are used to acknowledge which tile you have received in a window, timers, counters, etc. So you have a listing of all those stuff and what they look like. And eventually, the last part is the algorithm. It's what you do with your stuff. What is the mechanics? And we have these four modes that we had already: the no-hack mode unchanged, the hack always mode unchanged, except the text is rewritten, but it says it describes the same algorithm as before. And this hack on error mode that has been significantly changed over the summer, which I call new. So again, you'll see those kind of drafts. A packet is cut into pieces called tiles. They may or may not be of the same size. Some modes require that they are the same size, but some don't. And if you group them by windows, and you have a window number, a tile number into a window, and then you might manipulate stuff with windows. We have made a clear distinction between the pieces of data, which are the tiles, and the messages, which we called SHIC fragments. In earlier versions of the draft, there was a confusion between the piece of data that is carried by a message that sends that piece of data. So now the distinction is very clear, and you can have one message that carries several pieces, several tiles. Okay.
Excuse me, Dominique.
Laurent, yep.
Clarifying question here.
Yes.
You said the tiles are for different sizes. I understood that the fragments have a different number of tiles in them, but the tiles in the packet are the same. So just the wording you used, that isn't clear to me.
Okay, so let's state that again. In the general description of the tools, the tiles are pieces of data. The SHIC packet that you have to fragment is cut into pieces. And in the general section, we don't say they have to be the same size. Typically, in no-hack mode, you cut as you send messages, so you cut enough of data that fills your L2 frame, and so that could be different sizes. You don't have to have them the same size because you don't intend to retransmit them anyway. So in the general description, we don't mandate that tiles are the same size. But in each of the modes, no-hack, hack always, hack on error, we do specify if they need to be the same size or not. Sure, thank you. Okay.
Okay, thank you. Okay, so I will go in more detail on hack on error because there is a lot of change since last IETF. So we work a lot. So I remind you that the goal of Icon Error is to minimize the number of acknowledgements that we are going to send. So in fact, as the name says, it's when you have an error, when you see that something is missing, that you send an acknowledgement, and when everything is correct, you don't send an acknowledgement. So the goal of this, of course, is to reduce the number of acknowledgements you will have. And for example, in some LP1 technology, when the link is asymmetric, for example, downlink is very expensive, it's good to minimize the number of downlinks. So we have only one acknowledgement that is mandatory, is the one that acknowledge the all one windows, and that say that this is the end of the transmission. So with Icon Error, you are sure that you have transmitted the information to the receiver. So how we can do that? So at last IETF, we had some problem with Icon Error because we had a state machine that didn't work well, and we have some ambiguities, and it was quite difficult to solve these ambiguities. So the way we did to avoid this ambiguity, in fact, was very simple, but we have to find it, is to increase the size of the window field, or the W field, and say it's no more, in Icon, it always is 1 bit, and for Icon Error, it can be more than 1 bit. So this way, we can number all the fragments, or all the ties with a unique number, which will be composed of the W number, the window number, and the FCN. And when you will get an acknowledgement, this acknowledgement will get the window number and a bitmap that will represent the FCN. So this way, we can also limit the size of the acknowledgement, because we can have a way to solve this is to have a very big FCN field, and this way we will have only one window and we send a bitmap. But we can have trouble because, of course, this bitmap can be too long for the feedback. So this way we continue to cut it into pieces, and it solves a lot of things. And the other thing that is good with having a large W field is that now each packet, each type has a unique number. And so we don't need to synchronize very strongly the sender and the receiver. So it simplifies also a lot the implementation of the receiver and the sender. So what is a W field? So you have it here in the drawing here. So W, instead of being 1 bit here, can be any size. So what could be this size? So here we take an example to compute. So this is maybe the worst case scenario, because we have tiles, so unit that we are sending are on 6 bytes. So if you look at current technology, the worst case is 8 bytes. So 6 bytes means that I have 6 bytes of information and 2 bytes of headers. And we take the largest packet we have to send is 1,280 bytes. And if we do the computation, it means that we need 5 bits for the W field, and we have 3 bits here for the FCN. So all the numbering of tiles will be on 1 byte. So it's a little bit more than what we have in Icon Error, because in Icon Error we can do it in 4 bytes. Here it's the double, but it's not something that is unrealistic. So we with that, and of course, this is for the worst case. So you can imagine to have several rules in your context. One rule for large packet with a large W field, and for small packet that are more common, another rule that will have shorter fields, because it's something that is common and you use it more often. So this is quite flexible to use. So as I say, we don't need now a very strong synchronization between the sender and the receiver. In fact, the sender is sending all the tiles, and the receiver is sending from time to time a bitmap that say, I have not received this information, I have not received this information. When a receiver has received a complete window, then he will not acknowledge it. It's Icon Error. So we just acknowledge, or we send a feedback for error. So it's, as I said, simplify everything. And here, so we have the example that Dominic has shown before. It means that we have in Icon error, so all the ties have the same size. And what we do is we can send a packet, a chic fragment with only one tile, but we can also send a fragment with several tiles on it. It's next. Okay. Okay, yeah. So we send a list, a group of tiles here that are that have a size, and this size is the MTU of your packet. So here it's not really, so you have a window, so here we have the real numbering, so we increase the window number and we decrease the FCN value. So you start with 04, 03, etc., etc. So you reach the end of a window, then you send the next window, so 43210, etc., 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 until you finish to send all your tiles. So the last tile here can be smaller than the normal size of that you have fixed for your fragmentation. So what you have to do when you have a specific technology is to select a tile value, a tile length that can work well for all your MTUs. For example, in LoRaWAN, we have all these MTU. So the smallest one is 11 bytes. So you have, of course, to take into account the fragmentation header. So for example, if you take a tile of 8 bytes, then it enters into 11 MTU, etc., etc. So you can put more tiles when you have 33, etc., etc. So you can increase the number of tiles you are sending if your MTU change and increase. And if your MTU decrease, you can reduce the number of tiles you are sending. So why? So here we have a very small numbering or very precise numbering of the information, but the magic is that it doesn't increase the number of acknowledgement we are going to receive, because if you send something that is quite large or a lot of tiles, then you will send a full window. I think it's the next slide here. So you send here a full window from 6 to 0, and so you will not acknowledge this. If you have received the previous fragment and you have value from 6 to 4, then you don't acknowledge this one. And if you receive the next fragment with 0, 0, same thing, you will not acknowledge this window. So this small numbering of tiles will not generate more traffic on the radio. So that's the magic of this, and the advantage is that we can adapt to a change during your transmission. And we go to this unit that is a tile. So here we have an example. We have at the beginning an MTU that had us to send 10 tiles. So we are sending the first one. So the receiver receives it. The first window, window 0, is full, so we will not send acknowledgement. The second window, window 1, is not full, but it's a normal process, so we don't send anything. We wait for the next fragment. We send another fragment here. This fragment is lost. So the receiver, so the sender, of course, doesn't know it, send another fragment, and here we have, in the numbering, we have some hole, and so some bits are not, the bitmap is not full. So in that case, the receiver may decide to send the bitmap, and it takes the first one that is not full, and so it's for window 1, and you say, okay, in window 1, I have received this 3 fragment, or these 3 tiles, and then these are missing. The sender can have different behavior, and it's something new that didn't exist before, is that we have now to specify, and that's why we go to the name of profile, because we have to define also the behavior when you can send the acknowledgement. So in always, there is no mystery. After all zeros, you have to send an acknowledgement. Here, since we don't have this strong synchronization between the sender and the receiver, you can send the acknowledgement at some period of time that are known by the sender and the receiver, but are not only at the end of a window. It can be, for example, at the end of the packet. So you send all your fragment, and when you have finished, you send all the sender will wait for the acknowledgement, and then we resend things that are not being received by the receiver. Or you can imagine also some other technology, like slotted technology, where you have a channel that is slower for acknowledgement, and then you can send this acknowledgement during these slots. So here we have a lot of flexibility in the way we are going to do the acknowledgement. And of course, the sender and the receiver has to agree on the way at the time where the acknowledgement has to be sent. So it is specified in the profile. So the profile will specify the size of all fields and also some parameter like the behavior of the state machine. So here, what we have, so we know now that things are missing, but the MTU changed. So the MTU changed, so now you adapt and you retransmit a fragment that contains only 3 tiles. So you complete a little bit your window, is not finished. Then you send another one, it finished the window, it finished this window. So window 1 now is full, so we remove it from the acknowledgement. And Windows 2 is not full, so we receive, the receiver will send an acknowledgement, etc., until all the missing fragment has retransmit. And we go to the old one, and then we have an acknowledgement for the old one that say make OK. And in that case, of course, it's and we know that the packet has been sent. So that's the way the protocol works. So it's quite, it's very powerful. So as I say, we have a lot of good property we didn't get before. The first one is that we have a very simple state machine, but now, and the implementation is quite simple. And we have different behavior that can adapt to different kind of technology. We, in good condition, we just send a very small message that say, make OK. So it's few bytes that say, I have well received the information. And in case your transmission is not so good, then you increase the number of acknowledgement you have to receive. So we are going now to, we are doing some studies, but in fact, the worst case is when you have one missing fragment in each window, in which case you have to send an acknowledgement for all these windows. If you have more than one missing packet per window, you are winning because you send only one feedback for this window. And if you have no misses in your window, then you send nothing. With that, we can adapt to MTU variation, which was not so obvious. And the cons of this is that we have a W that is a little bit larger, but it's not so bad. We have to define now a new parameter, which is the acknowledgement policy. And the other thing that is not as optimal as in always is that now we may have some extra bit of padding at the end of the list of types. But it's also something that is less from 7 bits. And the other drawback, but it's logical, it's something that comes from the algorithm, is that you have some technology, for example, if you have downlink fragmentation, you need to receive an uplink to send the next downlink message. Of course, here, since we are reducing the number of acknowledgement, then of course it will not work. So we have to impose a message every time, or we have to see with layer 2 technology if there is not some way to send more downlinks consecutive without uplinks. So it means that here we have a very, very nice fragmentation protocol that works quite very efficiently for LP1 networks. Okay, if you have questions.
As the chair of this working group, I'm very proud of the work and how it happened on this particular draft, and in particular the reaction to the work group last call primes on the fragmentation, and how the team has been working hard through summer to fix that and produce this absolutely excellent solution for this prime. So thank you very much, Laurent and Dominique and all, Juan Carlos and all the guys. If I can add two things. You know that Laura is one of our kind of customers for this work at the IETF. And I have attended a meeting like a month ago where they were discussing how what they needed for fragmentation and how it could happen. And so there was this technical proposal. I can't detail the proposal, but what struck me is that it was done completely in parallel to what has happened here. They studied what they needed and how it could work and how to make it optimal. And there was this guy, Mark, who presented his view on that and his solution. And it was like 95% exactly the same as Aconera. It was incredibly, very much the same. And it was done totally in parallel. It was completely unaware of this draft, which tells us that we are very, very close. It's like having two implementations that work together. Here, it's like two designs that converge to pretty much the exact same operation. And so I told that to Mark, and then I gave him, the access to the draft as it was still a draft, and he read it, and his conclusion was, "Wow, that's exactly what we need, right?" So I hope, Laura will be discussing what they do, right? But there is this clear hope from my standpoint that our solution and the convergence of IETF and LoRaWAN on this particular subject is bound to happen. So we'll discuss that next. So that's one thing. And then since he did all this thinking total parallel to what we are doing here, I asked him how he saw it working, in particular when you have the downlink that you are talking about. So the data is coming from the internet, and the device is asked to in class A type of operation, which is also close to what Sigfox does. You have to pull the data. You send something, and that's when you open the return channel to get the next fragment, right? So I always envisioned like the device would pull fragments one after the other whenever it wanted. But when I talked to Mark, his view was not like that. So that's what really surprised me. His view was like the device is doing its own life. It's sending its data, like publishing its measurements or whatever. And each time, effectively, completely asynchronous to the fragmentation, but each time he sends one data, he will receive one fragment. And that can last for days. So his vision was not like, let me pull fragment, pull the fragment, pull the fragment so that in the next hour I have the message. No, I will publish a data like daily and I will get a fragment daily. You see, and so for some information which you don't need tomorrow, like the next image that you will flash in a month, his view was like, you will just exploit the fact that you're publishing data every so often to get the next fragment. But this fragmentation process that you're describing may last for days. So it's just a way of figuring that out. That just struck me as surprising. So I don't know if you like the anecdote.
Yes, and so to add to this point, I'm also really glad of the whole work that was done during the summer time and after. So that's really some amazing job, guys. And at the last IETF, there were these discussions that, okay, well, we feel that everything is working really well, but we could do, like, we can find some way to really improve the efficiency. And so that was essentially the work that was done during the summer, and this huge work of actually improving the readability and applying all the things that were said during the last IETF. So huge thanks for doing that work. And I'm also very hopeful about actually getting this technology to be in the core of all major LPWAN technologies, right? So I think that if we really get the adoption from the LoRa Alliance, and Sigfox is here, and NB-IoT and LTM, to use SHIC in the core of the fragmentation and the compression, which was not initially the goal for fragmentation, right? But that would be also something really, really amazing. Yes, so we'll be starting. So the fragmentation part is now pretty like really improved. So we feel that it's ready for a working group last call, to start after this after the IETF, after this IETF, and please do provide your comments. So the compression part, we're clear on that. So don't spend too much time there. I mean, you can add some minor editorials, or if you find some typos, but please do focus on the fragmentation part. And we will be talking about rechartering. We are very clear with Suresh that we will be able to recharter after we submit the document to the ISG. So I would love for us to send the document to the ISG before 15th of December. This way, it's like not just before the holidays. So this means that, if you want to provide some feedback, please do it. It's now, right? We don't wait for 15th of December, because the team, they also want to spend some holidays at some point, right? And they have spent enormous amount of time in actually improving the documents. So, yeah.
Yeah, Suresh Krishnan. So that's fine. Like, that makes sense to me. But nothing's going to happen to the draft really, like, before January. If you send it to me 15th of December, usually it's not considered good form to do a IETF last call during the holidays. So I'm going to have to hold off until January. So if it comes to me by the 1st of December, I can probably get it done, like the last call done before the end of the year, and then put it on a telechat, like the first one probably I think is January 3rd or something. I can do that. But if it comes to me 15th of December, expect it to go on a telechat probably end of January, because like I'm going to start the last call in beginning of January and then schedule from there. So just to...
Yes, it really depends on the amount of comments that we're going to get. So we'll launch the work group last call, unless somebody now comes to the mic and say we're not ready. We'll launch the work group last call right at the end of this meeting for like 2 weeks. And just depending on the amount of work that's to be done to resolve the issues, since we already went through last call for the compression and for most of the fragmentation, I don't expect that we'll get so much concern.
Yeah, as I said, don't hurry. Like, if you can get it done, but just don't like rush yourself. Like, if it happens like 22nd of December, like, don't worry, just push it, because I'm just saying that additional week, if you had to take, like, still people get their holidays and everything. So just like push it to me whenever you're ready to go, and I'll get the review process done after.
Hi, I'm Charlie Perkins, and I'm not meaning to complain or and make big delay or anything, but I just want to mention that it's a highly non-trivial protocol design, and fragmentation in general is known to be a source of aggravating bugs. So you should also solicit the detailed opinions and reviews, as well as trying to get people to do it in a hurry.
Certainly. The fact is, for this particular work group last call review, we are asked to have a deep focus on the fragmentation. So the document is huge, kind of, and there is many things, but like you point out, the changes since last work group last call are in the fragmentation. So knowing that we can focus on this piece, we hope that in the next 2-3 weeks, people can actually give us the review. The other thing is there are implementations around here, and at least 2 that I know of. So that helps a lot get some bugs out. I mean, I really love code for that. And with this, we'll have Juan Carlos for Sigfox.
Thank you very much. So I'm Juan Carlos Zúñiga from Sigfox. I'm presenting an update to the SHIC over Sigfox with the co-authors, Carles and Laurent. I'm pointing here to version 4. There's already a version 5 that was updated a couple of days ago, but it's very minor clarifications and details. Anyway, this is work in progress, because of course it's based on the latest version of the SHIC draft that was published just at the very end of the cutoff. So what we did since the last version is some further clarification on the text, but mainly focusing on the new functionality that we just worked out, that Laurent explained on the ACON error. This is a major change, as you've heard, and it opens up a lot of possibilities. So we first wanted to make sure that we understand and the baseline covers all the different possibilities. And of course, then this draft will take advantage of these new possibilities. So that's the plans for the new upcoming versions. So far, what we did is optimize the fragmentation parameters for a single byte of overhead or of SHIC, which gives us comfortably up to 300 bytes transmission in the uplink. And of course, we can still play with the parameters and get a higher or larger payload if we use a different header. On the downlink, right now we didn't work out too much because, in fact, I was having the same discussion that Pascal just mentioned yesterday with Carlos. The fact that we now can acknowledge things way in the past changes completely the paradigm that we had before for the downlink, where we were requesting on a window every single fragment. So we were having the exact same conversation, like, wow, now we can just get downlink packets for ages, and then say, by the way, last year you sent me something and I need this one fragment, and it will work. So we need to rethink that the downlink, and so far the draft is not reflecting that icon error possibility that it's opening up. So that's the part that it's still needed. I guess what I want to just clarify, because last time I showed this slide where I was pointing out that in the previous version of icon error there was an issue that we had identified where missing one packet in two conditions. There could be the consequence of aborting a session, either if an old zero packet was lost at the end of a window, or if any packet was lost during the window, and then we lost the SHIC ACK. Either of those two packet losses would lead to an abort, and that's the issue that I was raising. If you remember, the proposal at the time was to be able to go back not one but two windows. But as Laurent just explained, with this new possibility, it's not two, but it's very much up to the designer how many windows you go in the past. So the issue has been not only solved, but actually improved a lot in the way the protocol now works. Again, opening up a whole bunch of new possibilities. The other point that is not mentioned here, as Dominic described before, is the MIC. So far, we've seen that the use of the MIC is mandatory for UDP to comply to IETF rules for UDP IPv6. But we believe that we may not need the MIC in some other situations when we are not sending necessarily a UDP packet, and this could be just a control message for the specific radio technology. It could be a small config or something like that. So for that reason, right now the text is proposed to be mandating the MIC for the UDP transport, but leaving it open to the specific technologies for non-UDP traffic. And so actually, this would be perhaps a question for Suresh. I don't know. So far, do you see an issue if we mandated the MIC for UDP traffic, and we leave it open for other type of traffic? Because that's been a discussion internally whether this is acceptable at ISG.
Suresh Krishnan. So I personally don't see an issue, but if something comes up in the IESG, like I would of course want it to be handled at that time, right? So I don't want you to worry about preempting stuff in the IESG, even though that it might come up as an issue, but I personally don't see it. If you have UDP covered, I don't see an issue right now. But if something does come up, we can handle it at the time. So, and I'm open to that if the working group is okay with that. So that's okay. So if you see consensus here to just say UDP is mandatory everywhere else, figure it out, right? That's okay, as long as it's clear what somebody needs to do, right, for a given scenario, and you can still have interop implementations. That's pretty much my worry. So other than saying, okay, I'll do some hand wavy stuff, that's not okay.
Right. So that'll be part of the rules definition. But yeah, that's a good feedback. The interoperability. I think it has to be with the profiles and all the discussions that we've been having. So we have to know there are a lot of optional parameters, so we have to know precisely what's the agreement between the two sides before they communicate.
Yeah, Pascal has that evil smile, so I'm
It's
waiting
not
to
an
hear
evil
what he's going
smile.
to say.
Is that we've been discussing one particular item related to UDP is the UDP checksum. So the real problem with UDP is the UDP checksum. In 6 Lpwan, I was doing that. So I went through the hassle of convincing the ISG that we could elide, in some cases, the UDP checksum. Before that, there was the case of tunnels, and the ISG understood that you don't have to have a UDP checksum inside the UDP checksum when you tunnel UDP into UDP or something like that.
Right.
6 Lpwan was a bit different. Is at the transport level, we know we have an additional message integrity check, which is actually larger than the UDP checksum, and that covers what goes into the pseudo header that is used in the UDP checksum computation. So basically, with 6 Lpwan, we have this capability to signal from transport down to the 6 Lpwan layer. Hey, guy, I have a MIC, a message UDP check, which is encompassing what the UDP checksum would do, which is better than what the UDP checksum would do. So you don't have to transmit the UDP checksum, you can compress it. Here, we won't have that. I don't expect, well, maybe you do. If you do, then I
No,
guess
but
that
like,
passing 6
I think Juan Carlos said like UDP will be mandatory. That's what I understood he said.
The point being that the UDP, my understanding of this particular problem is about compressing the UDP checksum. It's not just which transport you use, is can you compress the UDP checksum? And that will be a fight because right now the MIC is not at the transport like 6 Lpwan, it's on an underneath layer 2. And so we'll have to explain exactly when we think we can reasonably elide the UDP checksum, and we'll have to convince the instances above that we don't break IP or UDP by eliding the IPv6 UDP checksum, which is mandatory in 8200.
Can I just add a technical point, Dominic? Right now, the MIC is on the fragmentation part, not the compression. So you're talking about eliding the UDP checksum at the compression, and we have a MIC at the fragmentation. So it only works if we do fragment the compressed packet header anyway. So just to mention.
So basically, each technology document can propose a way to allow for eliding the checksum, but it will have to prove that we are not losing anything, because otherwise that will be a fight. When it's coming from transport, I mean, it comes after the UDP encapsulation and decapsulation. So we know we protect the inside of the UDP. If you do it underneath, even for fragments, there is a time in the stack where you have a UDP checksum which has been recomputed, and you have lost already the protection of the mix. So it's a slightly different thing. Some people may come to us and discuss that. I mean, just let's be prepared and let's have good arguments.
Right, Suresh Krishnan. So Pascal, can I suggest something? So I see that you're worried about something. It's not clear to me what exactly that is, right? So if you can write up like saying, okay, like, if there's bit corruption here or like some bit error happening here, like what exactly happens, right? So throw the scenario to like, Juan Carlos and Dominique, and then we figure out from there, like, is it going to be caught or not? Because like we did the same exercise when we did the zero UDP checksum in 6-man, right? We said, okay, like, what happens? Like, okay, let's say the port gets corrupted, right? So is it going to be detected or not, right? And that kind of thing. So like we can probably do like, take like a failure case, and then we discuss it and see where we go from there. So if something else is going to catch it, then like, everything sorted out. And then good thing is like we're happy here. And then we have like already a paper trail, like for the IESG saying, oh, we thought about it. This is how it's going to get caught. And then it helps us. So just like, think of like whatever, like throw all the failure scenarios that are possible in there, like, L2 stuff, like L3 stuff, anything, right? And then we go from there, like,
Completely convinced. I mean, that's just raising awareness. We are more and more prepared for that fight and all the arguments, yes.
I don't know if it's going to be a fight. I think it's going to be like something probably
it's
awesome.
A Muay Thai fight.
Right. No, it doesn't have to be a fight, right? Like, so the thing is like, so one of the things like I kind of recommend to the chairs, right? If something like this has been discussed and you expect there to be a fight, just put it in your Sherpa write-up saying, okay, if you're going to ask about this, like, there's this like one section, it says like, is there anything remarkable in the working group process? You could say like, hey, like people are worried about the checksum here and and this is how we discussed it. put a pointer to the mailing list, everybody reads it. Like I read like Shepherd write-ups for every draft I read. Okay, before I read the draft, I look at the Shepherd write-up and say, okay, like what did the Shepherd think of it? Like, is there something funny happening in the working group, right? So I do that. So just throw it in the Shepherd write-up, and then like we can preempt a lot of the fight, really, right?
Let's just make a ticket proactively on that so we can track anything in the ticket.
Okay, so yeah, we can see that you're still suffering from your scars, but
Like Suresh said, it's
can
not
take a more
scars, right?
pragmatic-
But you have to very, very carefully craft your work so that you effectively don't leave a hole. And they ask you to be serious about what you do, so you'll do it.
Yeah, perfect. No, and I think that's a good pragmatic approach to say, okay, well, yeah, this is how we thought about it, and this is the solution. And yeah, something to keep in mind is, as Dominique said, that there's two functionalities right now, the compression and the fragmentation. So one thing is aligning the checksum, and another thing is adding a MIC at the fragmentation level. So make sure that it's well addressed. Okay, so I think I'm done.
So there is, Juan Carlos, can you just for a second, because we had in the program, I didn't see the slides there about this. So we currently have in the charter 2 charter items, and the first charter item is we've done it. The second one will be expanded, and one item there is actually the technology dependent documents. Yes. So we've been working quite a lot since the beginning. Right now, you're a co-author also of the main document. So congrats about that.
Thank you.
And thank you very much. So would you be, I think that's, things have been there for a while. So would you be willing to ask for adoption?
Sure.
I mean,
Sure. Thank you very much.
There was just no slide. This is why I'm asking.
Indeed. I didn't put a slide, but I saw it in the agenda, right? So yes, again, now that the baseline draft is pretty solid, of course, there's always room for improvement, and we are going to fine tune it, but it's pretty solid. So I think right now we feel confident that we can work out the specific draft, and we would like to call for working group adoption, if that's okay with you guys. And I also forgot to ask if there was any question specific about Sigfox.
Anybody has a strong reason to oppose the call for adoption? Please come to the mic. Well, the call for adoption is just a call for adoption, right? But yes, I mean, we want to work with last call of the other thing to be, but it's good to know. It's good to know that. I mean, usually the people have already read the draft and they just say, yes, it's ripe. I mean, we don't expect necessarily that they'll do the review now for just a call for adoption, but yes, I mean, I understand.
So just to clarify, for you, it's important that we finalize the SHIQ DPIP before we actually go to adoption for the specific technology documents.
Yeah, like pending, like a recharter kind of thing, right? So
this is already chartered.
This is in the charter.
We'll go through the charter discussion.
Okay,
so maybe we
you're
can.
not talking about the LoRaWAN stuff.
Well, the LoRa, the Sigfox, NB-IoT, and IEEE are all part of the charter. The technology.
But we don't have milestones for it yet.
Well, we can't.
Do you want to add the milestones before, like we take up the recharter? Like because I'm pretty sure, like I didn't approve any milestones for these.
Suresh, we'll have like 20 minutes on the rechartering, so maybe we can postpone and let the guys do their presentation. Okay. Yes, I mean I agree with you. It's just that maybe we can delay that discussion.
No, I'm just fine. Like just say like that's fine. Like how much interest is there, whatever, and do a formal adoption after the other things are getting pushed out. Right. That's pretty much it. Like because there's no milestones.
Okay, yeah, I mean, and with the rechartering, we'll put all the milestones. The point is, this was more exploratory. We wanted like the technology to feed into the SHIC, so we know the SHIC is complete. And thanks to work like this, I mean, Juan Carlos, for instance, has helped us tremendously do the SHIC thing. That's to the point that he became a author. And so that was very important for us to start this work, but not to complete it. We could not. Actually, those drafts will depend on the draft which does not exist yet, which will be rechartered about the profiles. Because they will have to check on the profiles what they declare here and what is left to implementation. And as long as that work is not complete, this work cannot be complete. So, I mean, yes, we couldn't have a milestone so far, but we wanted this work started.
Okay, like as I said, right? Like let's I just want like some closure on like the existing milestones. It's not far, right? Like, so like, Charlie is a bit more skeptical, but like, if I see the document getting out pretty quickly, and I don't see why not. Like, Charlie, are you promising to review the document like for fragmentation? Are you promising to review the fragmentation pieces? Okay, Charlie said like he read 10 pages of the draft and he sent some comments on the list this one. Of the fragmentation part. Okay, cool. Okay, so so if that's done, like, okay, like let's not gate on it, but like, I'll be really happy if it gets done and shipped out of the working group, and then because I'm very happy personally with the progress the working group has made. Like, it's been like always at a good rhythm and getting things done. So I just keep it going like that. And since we are focused, because if we spread out too much, like before the other things are done, because I do see quite a path ahead for the other drafts too. So it get pushed out of the working group. There's going to be IESG stuff, like, right? Like, sometimes like, I'll give you an example, like probably a bad example. You probably won't be happy, like 6-dish minimal, right? It took like quite a bit of time after it got out of the working group, multiple attempts at it, and like the cadence was completely lost because people moved on to other things, right? In the working group. So that's kind of something I want to avoid going forward.
So, okay, so it's understood. You need milestones, and these milestones are like dates, and they are dependent on actually getting SHIC to the ISG. So that's pretty clear. One of the points that we were thinking about this adoption was also to signal to other SDOs that, okay, there is this document. Now, if you want something done, please go, and that's the document that thinks that work is getting done. But of course, yeah. So we finished the first SHIC, the SHIC IPUDP, and then and then we invite everyone here and the people that also are on the mailing list to consider very deeply if they have anything against adopting the different documents that are accepting, and then we can do a pretty, like on the mailing list, call for adoption. Okay, perfect.
Yes, the point being that this work has mostly enabled the technologies to help us on SHIC. Those documents are not thick. There is very light work actually being done yet because they need the real SHIC to be there, but it has helped build SHIC. And if you look at the history and the diffs over the last like 6 months, you'll see that the attention was on SHIC, never on those drafts.
Okay, hello everyone. My name is Varu Petrov, and I will be presenting the work for Layer 1 on SHIC on Layer 1. So I will start by presenting the work that has been done after the last. Okay, thanks. So I will start by presenting the work since the last IETF, and then continue with the next steps. So we have not published a new version of the draft. We are working on it right now, and you can see it on GitHub. The reason for that was the addition of icon error, so we wanted to consider it and implement the things, provide the needed parameters for it before we publish the new version. We managed to get some feedback from Dominique, and that helped us improve the draft, so thank you. And yeah, we fixed things with padding. We added some new features, some new descriptions for the Layer 1 details on the draft. We also improved the terminology section, and we added security considerations, and also made it possible to see directly in GitHub the new versions of the draft, so that you can read it more easily. So there are a few things to do yet. We need to see how to do the IID computation. We need to introduce in the draft the TARs and device profiles, but I think the device profiles we will need to discuss a little bit further before we do that work. And then we are currently looking at Aconera. We think it's a very nice addition, so we will, I think we will be using it for sure. But yeah, we are currently studying it in order to include it. And we are waiting for some feedback from the Law Alliance if there are some changes that need to be done and all that kind of things. So yeah, and the last thing that we also need to do is provide some parameters more explicitly. For example, the word is 1/10, but 1 byte, but I don't think we have it anywhere in the draft right now. So for the next steps, we also think that we are getting very pretty much ready for adoption, but we'd like to hear your opinion.
Yes, thanks, Ivailo. I think for the adoption, we will we get the input from
Yeah.
Suresh. So we'll be waiting for for us to get
Okay.
the SHIC document. But as everyone is invited to go again over the document and explain.
Yes.
Just starting thinking about it.
Yeah, and any feedback will be greatly appreciated. Okay, so thank you.
And we'll call Charlie to the bar.
Good morning. I'm Charlie Perkins. And I have a very short presentation. We have, and so this is just about IEEE.
No, you both. I mean,
We'll do both.
everything you have, because we can. Okay, so you have two slots, and we
Yeah.
kind of merge them now. So you were sure that you could say everything you wanted to say, and then we spend the rest in the original train.
Okay.
So basically, we are the variable part.
That's fine. Well, so in IEEE 802 wireless, there's a task group 802.15, and about for the last couple of years, there's a group called 4W 802.15.4W. W stands for wide area, low power, basically, and it's been an interest group and a study group, and now it's a group to actually produce a standard. And there's been a number of approaches that were brought forth. I listed them here, and I don't really have to, I don't want to go into detail because actually it's not my area of expertise, but I just want to mention that there's a surprising amount of creativity about this. For instance, they have a proposal where you just have a huge number of error correction bits. That's one possibility. Another possibility is you do kind of some sort of repeater operation where you have extremely tight synchronization between the essentially the backbone nodes and so on. So it's an interesting set of proposals, but since the last meeting and during the interims, it was determined. I should point out that there's interim meeting. There's 3 a year where it's face to face, and then they have teleconferences, which are also called interim meetings. But since the last face to face interim meeting, it was the teleconferences. They worked on actually merging aspects of all these proposals, and that is now available for members of IEEE 802 wireless. But it's really mostly at the file layer. And so the other work that's going on in 4W is to produce this coexistence document. And oops, sorry about that. Okay. So this coexistence document, a lot of these are pretty much pro forma, but now there's another group called 802.11 AH for low power, and we're trying to make sure that none of this stuff interferes badly with 802.11 AH. Okay, so that's what I would suggest is mainly the IEEE 802.15.4W status update. Yes, JC?
Yeah, sorry, this is your last slide on the IEEE? Yes,
Yeah.
thanks. Juan Carlos Zuniga here. So I missed the last meeting, as you probably noticed. And I'm just curious because here, when you say a merge approach, you have the whole list of proposals,
Right,
including both Mac and Phi options.
right.
So everything got into the...
No, not everything, but all the proposals were deemed to have some aspects that might be worthy of inclusion in the overall document. I think that the main thrust of it is to have, actually the diagram that's shown looks almost like a six-tish diagram where they have a sort of very small fragments that are spread over time and frequency. And the reason for doing that is that they really, interference is bad for low power wide area, and if you have additional redundancy with small fragments, they've measured pretty good performance.
Okay, yeah, which is the scope of the group to just work on a more FECs for the 802.11.4.
Yeah. So
G.
right. So this is the main thrust of 4W group, and I didn't bring anything else to talk about the other part of 802.15. So should I report on the other parts of 802.15? Not today, but for next time or something.
Well, we like that you do it pretty much every meeting.
Okay.
So you always have this AOB type of window if you can just tell us the news from IEEE. So it's always good.
Okay.
So a few words. I mean, we have time.
All right, so there is other relevant work, but the other parts of 802.15 that are going forward really are not so relevant to low power wide area, which is why I didn't include it here. So next time I'll put more in about that.
On that point, just a short question, Charlie. So all these people, they are aware of the work that we are doing here, in the work that is happening in this working group, and things that they could use.
Yes, everybody in 802.15.4W is aware of this group and of the document that we have submitted to this group.
Okay, perfect. Thanks for that. Yeah.
Because the chair likes this, and so he emphasizes it. Okay. So our other the document I just mentioned is this SHIC for 802.15.4W, and this has not changed recently. The reason was because mainly what we have left to do is to decide about whether we're going to have a fragmentation part of the profile or not. And since I wanted to wait until understanding the new release of the document before making any changes to the SHIC document. So it hasn't changed. And reading this SHIC release number 17, there's an appendix D, which is extremely interesting for document authors because it tells you what you need to put in your document. And since I just saw that, that needs to actually try to include all the suggested guidelines and parameter and profile parameters and so on, which will have the effect of reorganizing this document. And I fully expect that we'll have 01 maybe before next year, but certainly before next IETF. But there is a little bit of organizational detail about this. First of all, this document is not an official 802.15 document or not a 15.4W publication, but as I mentioned, these folks are interested in this because they do want to appeal to an IPv6 application domain. So this has undergone some numbers of discussion and improvement within the 802.15.4W. But there's been a little bit of an organizational change. In 802.15, there's this thing called, oops, I keep pushing the wrong button. There's a standing committee for IETF, and this actually, they pay attention to everything from core to 6-low to roll to low power wide area networking. And since the main thrust of 4W is living down pretty close to the PHY layer, they thought it might be worthwhile to actually try to move the work into the standing committee of this 2.15 standing committee. And so that essentially has happened. And so hopefully we'll also be able to have some good input from the people that attend the standing committee. So the last thing I want to mention is that in the current draft, I'll show the next slide just briefly. So what has not changed since the last IETF was this design, which basically we had thought we would just use fragmentation. 802.15.4 already just specifies a fragmentation technique, and we can use that. And since if we did use that, we don't have to worry too much about these profile parameters. But it is an open question whether the SHIC fragmentation is better than 802.15.4 fragmentation, and it could be because it's pretty good. And so I need to actually do the arithmetic on some various cases, like for instance, UDP with IPv6 and so on. And that's a lot of sitting down and sort of tedious work, but it really needs to be done. And the result might be that we'll say, well, we really want to use SHIC fragmentation, and then we'll define these parameters. So that is what's going to happen next week. Next week in this very hotel, IEEE 802 Wireless will meet along with 802.15.4W. And you're welcome to come. We love people to come in. And so that'll be a matter of discussion about whether to use the fragmentation reassembly from the SHIC design or not. And another possibility is that since we already sort of got started doing the SHIC context, static context compression idea, well, maybe it's applicable to other 802.15.4 documents in addition to 4W. Now, whether or not the 4 other .4 documents really apply to the static context as defined by this group is there's, for instance, there's some 802.15.4 work that should be applied to networks up to 10,000 and many hops in a mesh. Well, that's probably not a good candidate for this, but there may be some other ones that are, and so that's another topic of discussion for next week. And so that's my presentation.
Many thanks, Charlie. You made me I had three reactions to what you said. The first one is you mentioned that because of the NXD, you will have to reshuffle the document. And part of the next discussion is about probably having an RFC for NXD, like having a full description of everything you need to profile. Mm-hmm. And then your document, every protocol-specific document will actually specify classes of profiles that are matching this particular technique. So I hope that we will find some similarities in the way the documents are structured. So somebody who wants to see, what are Sigfox profiles? How do they look like? How do W profiles look like? Or how do LoRa profiles look like? They just go to the specific document and they see, those parameters must be in that range. Those are not specified, but if the structure, like you said, the restructuring could be agreed upon within those documents, then they would all become much easier to read for somebody who wants to build a generic code that would work for all of them. So yes, I completely agree that that's nice to reshuffle. I think you will need the data model, the full data model that we want to reach out for to have this work complete. NXD is very good, but we want a complete set of parameters to be an RFC that you can refer to. So that's pretty much where we think we are going with the rechartering. Mm-hmm. So not only, yes, you need to do it, but also maybe try to work with the other technology-specific document to have some homogeneous ways of representing that, maybe based on the data model that's coming up.
Well, so I agree with you, but in particular, after going through the exercise of having the interest group and study group for the 15.4W, one of the outcomes of that was a pretty good analysis of which radio modulation schemes were good for various applications. And in particular, we know the kind of applications that are to be addressed by this work. And so since we know the kind of applications, we might be able to predict some of the packet formats. And if we can predict some of the packet formats, we can make better compression. So there you go.
So just a question here, a second. You mean that potentially there could be like different profiles per application?
No, we have a good list of applications, you know, all the normal kind of stuff like tracking your dog across town or whatever.
The second reaction is and then again, it's a praise for this working group, guys. All those technologies we've been designed to charter to work on started without IP in mind, to be honest, right? When you start a new technology like this, you have layer 2, you have application data over it. And you think IP will never work there. I mean, I've heard that for everything which became 6 Lpwan. And I've heard that for everything that became Lpwan, IP will never work there. And this WE4 is the first one which starts with, oh, IP is almost a given. Let's see how SHIC works with us, right? It's an incredible twist of fate that now we are in the charter of the working group, of the IETF piece in this case, but on the technology piece, before they even start and do the work, right? And IP is not a second thought here. It's included in the very design, and that's because we have SHIC. That's because we've been there. So a praise for this working group. I mean, I really love it. And the third thing I had in mind was we were chartered for technologies, and one of them was IEEE. It was, well, you know which one it was. So it was basically 15.4 for sub-gig, etc., the YSAN type. And there was not much activity related to YSAN, but now we have activity on W instead. And I was just wondering that if as we redo the charter, should we, and that's really you in both, so should we kind of twist from focusing on YSAN to focusing on W? So we would still have 4 technologies, but maybe we would charter for this one instead of YSAN. Does it make sense?
So I will bring up that point next week. And by the way, I think somebody should write a book about all the technologies that IP can never work for.
Yeah.
But yeah, another question, but maybe after Suresh.
Yeah, Suresh Krishnan. So like one thing, Pascal, just to follow up on what you said, one of the things is like, I would like to happen. So let's say we want to go in this direction and say like, let's do like 15.4W. It'll be really good if we start talking about like how the technology is different from what we put in Lpwan overview. So that, I think that will be really helpful. Okay, because do you understand what I'm saying? Because you look puzzled.
Well, I was puzzled because I just wonder if we need to respin an overview.
Not respin, but at least like talk about what's different, because like we decide to go forward and just like say, okay, like from what's in Lpwan overview, like this is what is different, and then we continue with the work. I don't want to do a BIS document just for the sake of doing it, but I want to know the differences if there's any, because I'm sure there's going to be some differences here from what's in Lpwan overview for YSAM, right? So that's just my request in there. So if you decide to just follow this technology.
Or we may, I think we need the text equivalent to the overview. That's why I was already thinking about respinning. If we don't respin, we could also say, hey, Charlie, because you are not in the overview, then please have your own overview at as the beginning of your document, because I don't know.
That's fine. I'm open with the mechanism of doing it. I just want this written down somewhere, because we had this like, you know, beauty contest back in the day, right? Like to figure out, okay, I don't want to like, it's like a beauty contest really, right? Like, you know, we said like, okay, these are the technologies we're going to be interested in. We talked about them, we picked 4 and went on, right? So, so I don't mind respinning the doc, but we need like an editor. Maybe Charlie, like you could probably pick up the stuff. I don't know if Stephen like is around much here, but that's something open to. But I do want the technology to be documented, because what I don't want to happen is like, you know, only people who participate in IEEE read this document. So the main reason for me insisting on the overview was like people from the IETF understand what the technology is about, right? Like, you know, like Juan Carlos wrote about Sigfox, because otherwise the IETF people don't know about Sigfox. So it's going to make life easier for people who read the technology documents coming from this working group if I can point them to somewhere that's an IETF document, rather than saying, oh, you need to go sign some agreement with some other standards body, which may or may not be compatible. So that I want to follow the same kind of tradition going forward.
This
So
will
is this in addition to what was included already in the overview document by Steve Farrell?
Correct. So, so I'm expecting some diff in 15W, right, from what's written in Lpwan overview. I just wanted to put down somewhere in an IETF document.
Okay.
Yeah, actually, that sounds really great because, yeah, there are 2 points actually, and one of the points is I was coming to this. Probably we could find other ways that SHIC could fit into the W into 15.4W. For example, when you said that, okay, well, there will be maybe 10,000 devices and with multi-hop network and so forth, but SHIC can be applied to co-op.
Are we really going to do multi-hop SHIC?
No. But the point is no. The point is that we can. That it's a good thing to have a document that says, okay, we are doing SHIC for that particular application field, and actually that could be a way ahead in the future if there are other technologies that would like to to apply SHIC. This can be like the process. Okay, well, you want to apply SHIC, please write the overview. Then we see the diffs and we see how it is, and we can include your document. But it's and actually the overview document is super useful. Mm-hmm. It was the first document that's publicly available and that does an overview of all these LPWAN technologies, and it was really heavily cited. So I think that would be really great also for the technology itself. So we have to find a way. Yeah. Okay.
Just a small remark here. When we started 6 Lpwan, it was by the name just for 15.4, right? When we started 6-ish, it was just for 15.4E. Lpwan was kind of ambitious, starting with 4 technologies in parallel. Like compared to the other, it was never seen. Now, if we with 10 years of back off in front of us, we can see that 6 Lpwan has evolved to multiple technologies. So we have kind of respanned the working group as opposed to 15.4 to IPv6 over foo for a certain number of foos. And 6-ish, same thing, is now looking at sub-gig and probably different, even AX or something like that. So we can expect that the SHIC over foos will be one of the tracks of the future of this document. So we have to prepare. And this is a good example on how we'll recharter over time to do more foos. And we can really expect there will be more foos, right? So we have to learn how we want to do that. And like you said, the overview, how we do the overview for those new foos will be a critical part of that. So completely. And with this, we'll talk rechartering. So we have like half an hour, and so basically, since we were already last calling SHIC last time, we already started this discussion. We had pretty much the same discussion at the last IETF. We see there are 2 slight differences since what we discussed at the last IETF. So let's go through that. Maybe I go to the mic. Too old for this. Okay. So it's much better this way. So we had a number of chartered items, and I will go through them in the next slides. For the initial charter, it was mostly to do SHIC and SHIC co-op. And then we had this additional item of looking at the specific technology specific for documents for the technology we selected, but this was kind of mostly work started to make sure that we did a SHIC which would actually fit those technologies. So this was kind of ambitious because we had 4 technologies, but then we didn't want to do a one SHIC that would work just on one technology and have to change it completely for all the other technology. So that's why we took that kind of big risk of claiming we would start with just 4 technologies. That was actually huge. At the last IETF, and I will go through that in the next slides, we've looked at how we can refine this charter and split it and reshuffle it. And pretty much we're going through that discussion again and see that what has changed and what has not changed. So since the first charter, some individual submissions have come up to us, like work on ICMP, and we've discussed a pure compression of ICMP doesn't make any sense, but maybe some usage of ICMP could be valuable for us, and in particular things like OAM. So the discussions on rechartering are focused not on a particular class of message like ICMP, but a particular class of usages, like checking the quality of the link and feeding back the users, etc. So not ICMP, but applications of ICMP. And so we will see what makes sense for the recharter of this. So here is the original charter. And you will see that the second bullet here is kind of rich because it talks about co-op UDP, but it also talks about definition of generic data models, and it talks about the definition of various technologies. So it's one charter item, but if you look at it, it's a multi-sub-chartered item. So if we look at what we are near to completion here, considering that SHIC is pretty much done, the first big item is done, and this piece here, IPv6 UDP SHIC, is pretty much done. The rest of the way is not done. So as we recharter, we will have to consider removing what's done and then basically respinning what is in progress. Okay. So we can pretty much turn this piece here for what's left, which is co-op, as the first charter item. So this first charter item would not be new. It's just a respin of something which was not completed during the first charter activity. The data model, we always knew that the data model was critical. The data model is what you really place on the infrastructure side, so that you can dynamically, as you deploy a new device, you can dynamically change the infrastructure to support this device. SHIC is completely stateful, which means that it doesn't work if the network side, the network entities are not aware of how to compress the particular packets for this particular device. Each device may come with a new set of rules. If you deploy a new device, you must deploy the rules on the infrastructure. We need a data model for that. And the SHIC document has this concept of a profile, which is pretty much the abstraction that the data model has to implement. So this would become charter item 2. And the technology specific document highly depend on this data model, because they have to decide as part of this data model, what do they consider as open to the device? What do they consider as being fixed for their particular technologies? Or maybe some ranges of values for some profile data that they want to support, right? So pretty much, I see the technology documents as, at least one piece of the technology document, as being a way to express constraints on the profile. The profile is a very wide set of possibilities, and the technology documents will restrict those possibilities to what can be done in this particular technology.
Okay, just a comment on the first thing that is done. So we can add some new things. First of things, there is some case where we need IPv4. So,
later.
Okay.
I'm just going through the slides that we did last time. And then, as I said in the intro, some new things came up, and IPv4 is one of them.
Okay.
So it's coming. So if we're missing something in the next slide, when we talk about IPv4, that's when please jump to the mic. Okay, so this is pretty much, in Suresh, it's mostly for you, the kind of editing games that we'll be playing to go from charter 1 to charter 2. So this is the diff. Okay, diff 2 in the RFC. So you see that we kind of remove some text and replace it by some others. And once we do that, just erase the, thank you. So now it's highly visible what we are doing. So everything is really open. We are doing open standards here. And so basically all these editing games ends up with 3 work items which are really inherited from charter 1. It's just take charter 1, remove what's done, and split what's not done in the real individual items that needs to be produced. Okay. And now the new thing that we talked about last time inherits from the work that was done on ICMP. But like I said, we don't want to just compress ICMP. Doesn't make much sense. We want to comprise some particular values of ICMP, some particular flows that are useful for the LP1 use case. So now it's, again, we have these LP1 technologies, they know what they need. If the particular thing they need to manage their network, packet too big, I don't know, is useful, they need to come to and work with us on this particular topic so we can have a compressed way of saying that. Okay? And so we have to figure out which kind of, for instance, ICMP errors we want to support in this, or how do we do the equivalent of a ping, right? Because we won't ping over the LoRa network, but we want to produce something which has an equivalent result to a ping. So this is pretty much what this charter item is all about. And since last IETF 102, maybe you want to talk about this one?
Yeah, like Suresh Krishnan. So like about 2, like is there like a candidate draft somewhere, like for 2?
For 2?
Yeah.
That's not draft. Work, yes. We are actively.
Why are you looking at the watch? Like, are you going to write it in
How much time
minutes?
we have? Because no, I'm not.
I thought you were going to write it in 5 minutes. Like, oh, let me do it.
It's not that at all. It's that we have a surprise for you for the end, but I want to make sure we have enough time.
Okay.
And so once we are done with kind of this introduction, the recharging discussion, if time permits, we get additional slides about your questions. So I just wanted to make sure that we had enough time at the end of the meeting for answering exactly what you're saying. No, we don't have a document published. Yes, the work has started.
Okay. And for 3, there's going to be, if I understand correctly, 4 milestones, right? Not 1.
Yeah, 1 per technology. So if W becomes 1, and that's part of the 4 technologies that we discussed in the charter, not in the work items, we would have W, LoRa, Sigfox, and then BIoT.
Okay. And you don't expect like co-op stuff for each of the technologies or no? Do you expect any explosion there? No.
No.
Okay.
We just, it's like just like SHIC, right? It's more like co-op is more dependent on the application than on the underneath technologies. So we are kind of concerned that some people use co-op in a way that we did not foresee, and that we are missing a good rules, a good technique in our possibilities to compress that particular case. So the authors have gone through a lot of work. We talked with Carsten about getting some examples of use of core to see if we compress all those examples well. But okay. It's more like north than south, right? We expect more problems with the application layer than with the layer 2.
Okay. And will 4 include like bootstrapping somewhere or no?
Right now, the goal was ping and ICMP error.
No, it says operations, administration, and maintenance, right? So it's, would that, like, I just want to understand like better the scope of what you want to put in there before I say yes, because I don't want to boil the ocean.
Yes, probably we want, yes. Initially, it's kind of ping plus ICMP error. So how do you check the link activities, the link still operational, what kind of quality do you get? But I understand from what you're saying that we need to refine this to not
tighten it to exactly
yes,
what you want to
be
do.
More specific on what to expect. Like I said, in our mind, our discussions was mostly ping, like how can I emulate that? Do I need to really ping when I ping, or can I just use the fact that I just contacted the device to answer, yes, it's still alive, or this kind of game, and path MTU discovery and what else.
Okay. And for the last item, like the IPv4 stuff, right? Like, so one of the things I want to say is like if IPv4 works, that's fine. And I'm really reluctant to spin up IPv4 only work in here, just to like take care of v4 here, because I'm not sure like how applicable IPv4 is in like the IoT space very much. Okay, so it's possible that somebody has use cases there. I just want them to come up with it before we think about recharting. I want to see first somebody write up something saying why this needs to get done before I think about putting a charter item for that. Okay,
I understand you, and I'm like that. It's even more than that. I still fail to see that we have anything to do. Yes, Laurent will come to the mic, because my vision is like the device sending the exact same thing, could be using v4 and v6 and it doesn't even know, because I mean, what do you compress, right? A pair of IP address, a hop count, which is a TTL. I mean, what do you compress? And so basically, based on the same SHIC format with different rules, I could probably generate a V6 or a V4 packet, and the device doesn't even care.
Right, and that's what I said. So if V4 works, I'm really happy, right? But I don't want to put in specific effort to make just V4 work. That's what I was saying. So there's like a slight difference there, right? So if V4 works, that's fine with the way we specify it.
Or we could have an informational to say, oh, by the way, IPv4 works.
Just put it in the other draft saying V4 just works, right? Like I don't want to like have it.
In the current SHIC?
Wherever you want to put it. If something works for V4.
I just wonder where to put it. Exactly, that's what I'm saying. But maybe Laurent will tell us it doesn't work, you need to twist this, right?
No, I think IPv4 is more complex, so it doesn't work with what we have designed right now. So we have to make some improvement.
Okay.
Thanks, Juan Carlos Zúñiga. So I just want to pick it up from points 3 and 4 after the discussion. So for 3, there was a small concern about whether co-op will work or not. And I understand where it comes from because now we're writing specific documents and we're splitting basically in 4. But the whole idea here is to make it agnostic to higher layers, right? So we are just interfacing with lower layers technology specifically because they're very different. But from UDP and IDP should be completely agnostic and transparent. That's the whole idea of the interoperability here. So maybe we should do some homework if this is not clear for people, because that's a part of the big thing of this group, right? To make that interoperability work at higher layers. So I guess it's something that we should keep in mind. Maybe do a little more advertisement of what exactly we are achieving with these specifications.
But do you see work here to do?
No work. Just probably in the way when we write it, just keep in mind that the reader may get a little confused. I just realized that Suresh was confused whether co-op would need to be different, and just make it very clear that no, this is making interoperability work at the application level.
No, Suresh wants to make sure that co-op wasn't different. Like that, I didn't want like an explosion at another layer. So that's the whole point. But the part that worried me was that if somebody is trying to do like a more, okay, so the more layers you put in and combine them together, the better compression you can get, right? So I was like just worried that some technology, like maybe Sigfox, right? I don't know, right? Might decide to do like, hey, like, if I put in co-op together, then I can do something better than like, doing that. I just didn't want that to happen. So that's why I asked you, like, you didn't propose it. That's why I wanted to make sure that you don't want to propose it. So I'm fine with like what Juan Carlos said. If it has to be written somewhere, that's fine. But if I don't get a work item, I'm happy to. Like, so if it's like implicit that like, nobody's doing this, that's fine too.
But just for this particular question, if we see an IPv4 document showing up, I'm very happy. I don't know if we'll publish it in any fashion, but at least having somebody write about IPv4 so that the rest of the world knows, oh, you have that to do on your own if we don't publish it, but at least we know the state of the...
That's fine. Like that's also like, tells me that somebody is using V4 for IoT, right? Like that's something I would also like to know, because I know that like at least for IPwave, there was a company, right, doing vehicular stuff, and they said they were using IPv4. I don't know what else happened afterwards, right? That was Peloton, right? And so I don't know if it went any further or not, but at least I heard that somebody's doing stuff. I haven't heard anybody in the space doing that, but it's possible that NB-IoT has some stuff like for IPv4. I just don't know, right? Like last time I looked, no, right? But maybe there is, right?
Yes, that's where it comes from.
So just one point here, because there are actually two discussions going, the co-op and the IPv4 discussion, and I see someone on the mic that wanted to, I think that you wanted to say something on IPv4, right? No. Oh, it's not on IPv4. Okay, yeah.
So Pascal, since you brought it up, but like if something comes up, we'll handle it. I just don't want to lead with that, like saying like, oh, should we do IPv4 or something that somebody needs to write up to even consider it, okay? And I'm happy with what Juan Carlos said, okay, about this co-op stuff, that our convergence layer is IP, and I'm very happy with that.
And just to finish my comment, Juan Carlos again, on 4 for the OAM, now forgetting about IPv4 and co-op for a second, not getting back to that. So not to make it even more confusing. No, just focusing on 4. We started writing a draft, and indeed we want to focus on the ping and the trace route, if it makes sense. Well, maybe not, but not all the time, but mainly ping. And we are referencing to 1RFC that lists all the operations, administration, and maintenance functions, and we realized there's only two that make sense. So if it's better to change the title and make it more focused, that would work, because we actually try to go the other way around and say, okay, well, this RFC wants us to consider all these things, but only to make sense. So we actually started writing that to make sure we were focusing. But if we can write away focused, maybe that will help us out.
Can you send that to the mailing list? All this discussion, there is RFC, all the work items. These two seem to make sense to us, and then we can have this discussion, so we can tighten this text.
Sorry, Shushan. So that makes sense in the draft, but not in the charter. So like, the draft could say like, hey, I looked at this, like all these things, and these are two that make sense, can be in the draft. But like, I want the charter to be scoped to do what we want to do, not the things we don't want to do. Does it make sense?
Well, yeah, I mean, that's to trigger a discussion, right? But you asked us to tighten this group. So at some point we need maybe to list those two, maybe others, that would be the discussion. But you kind of told us don't leave it that open, right? So it's a starting point, but we need this discussion, and then we need to change this text. That's what I understand from you.
Okay, for me, maybe there is one point that is missing is about security and how we deal with security mechanism like the TLS of OSCORE. So for OSCORE, we include it in the co-op draft, but maybe we have to look at all the possibilities and see what is the best, especially if we want to go to management, we need security.
I'm a bit concerned that I like to see work started before chartering it, because I know we have people to do the work. I'm a bit concerned to charter TLS and have nobody show up and do any work. So.
No, okay, we have OSCORE, so OSCORE is
yes, that's why
works well, but so.
Because people cared about having OSCORE, the OSCORE work came up. Nobody cared about having DTLS. Curiously enough, we don't have any DTLS work. If we charter DTLS, nobody shows up. What do I do? Right? It's kind of, we need to show interest before we trigger DTLS. It's not, I would like it, why not? But somebody needs to say, hey, we care for it, we need it. And there's a force to actually develop it. So we can't just put it in the charter and hope it's going to come, right? I mean,
I agree, and also we also started having quite a heavy charter. So I would also like to see things getting done one by one, and not start 50 tracks of work and then we are not unable to deliver on the milestones.
Yes, but some points may be blocked if we don't have security. So.
Then we recharter. I mean, Suresh, if we have, like, we see that we advance pretty well and we have some demand on security, it could be pretty, I mean, and if you see progress on the other points, it's not going to be a huge discussion if we say, okay, well, now security gets a pretty big point. Can we include it in the charter?
I think security is implicitly included pretty much everywhere. So, like, if you have to do like a new binding, like for DTLS, that's okay. Personally, one of the things that was kind of happening in the OSCORE versus like DTLS kind of thing. One of the reasons for doing OSCORE is like, the DTLS may not be that efficient for the, like, the use in these environments, right? So if we have to do duplicate security mechanisms, I kind of want to see some kind of justification. But I agree with like Laurent that, like, this is like a blocking thing pretty much, right? Like, we don't want to do like, some kind of high level access to the system without like securing it. So I assume that it's going to be there, like whenever this mechanism is there, like it has proper security considerations, how it's going to be secured. So that's kind of assumed. I don't need it as like a charter item or like a milestone, but I expect it to be there before it hits the ISG. Otherwise, like, you're going to get a security discussed right away.
Well,
right?
Okay. The point being that we are going from a step to another step. The initial step was you had the layer 2 technology, which sometimes at the layer 2 security and network level security. And then right over it, you had an application which had its own security. We are inserting IP in the middle. We are not removing the application security that was there, and we are not removing the layer 2 security that was there. At some point, that's adopting IP UDP co-op, and then inside they do what they want to do. Now we are providing a score, and maybe in the future we'll provide DTLS. But we are going stepwise, and each step has its own security, and it started with the secure world, and we never lost the security that was already there. So I understand all you're saying. It's just that we need to have the use case, we need to have the people in the room who are ready to do the work. We cannot just put it in the charter and have nobody do the work after that. I mean, and then some people would say, hey, if we don't need to change SHIC, but just apply it, why does this happen in this room and not in COSI, for instance? Because they need to understand they understand the flows much better than we do, and then from there they can derive what rules they need, and they can check if they have enough stuff in SHIC for doing it, and if they don't, then they can come back to us and say, oh, we need to respin SHIC because we cannot encode the TLS. But are we the right guys to say what all those flows are? And I mean, it's kind of in between. If it really requires a SHIC change, then it must happen here. But if it's just how do you apply SHIC to do the TLS, then it may apply, it may be done somewhere else. It's just, it's not a discussion. So, but point taken.
Okay. Another point is about the point 5. So we have IPv6, but we don't have IPv6 extension. So at the beginning, we thought it was not a good idea, but maybe mobile IP can be used over Lpwan. It's a way to do roaming between different provider or to do between different technologies. So maybe it will be good also to investigate some IPv6 extensions.
Same as the TLS. I mean, yes, do some personal submissions, and we see the interest. And this charter is already heavy, so we wouldn't have a milestone for mobile IP, right? But why not have a personal submission and see the interest and start the work? And then if it's if it takes off, then why not recharter charter 3 on this, right? And for V4, yes, I'm like Suresh. I want to see the work, and I want to see what you cannot do, because yes, you cannot encode anything, but with what you can encode, you can already go through IPv4. So I mean, is it a game of doing the very generic thing, or is it a practical game of, is there a case that you cannot do that's very useful today? I want to see that.
So just to, I would like just to confirm something with Suresh. So the first 3 points seem pretty straightforward. The third point, if we add produce standard track document 1 per technology, so 4 documents, then that's pretty much, like limits the possible explosion of stuff around. And then, then with these, the first 3 seem pretty well defined.
The only question is W versus YSAN.
Yeah, the only question is W versus YSAN, but I see this like a separate step,
And
right?
Charlie will come to us next week about that.
Yeah. And then the fourth one, eventually we need some discussion on the mailing list just to narrow down what exactly will be done there. And for everything else, we need some submissions on the mailing list and like some reasons why we would need to do this. And I know that there were some requests for coming, so some specific things, but like on this during the interim meetings, but nothing really. From what I know, nothing really explicit and like a use case where, okay, well, we really do need this, and these are the reasons why we cannot do it as currently it's done. So that's like the fifth point. But at least for the first 3 points, we're pretty clear. The first one, we know where we're going, so we can do this the moment that we send the UDP, the IP UDP SHIC to the ISG.
So the target for rechartering would be when? After how much, because we have this target of submitting for publication, maybe end of January or something based on what you said. Is it the right time for producing the new charter?
Yeah, please, thank you. That'll be a good time to start the chartering process, discuss this in the group. Like, as long as you ship the document to me, you can start the rechartering process. So probably beginning of January, you can start the rechartering process in the working group itself. So put a proposed charter, look for discussion on it. And then when you're ready, send it to me. And it's probably going to be about, I would say 4 to 6 weeks after that for the charter to go through. So I need to put it in on a telechat, like for the internal review, then for the external review. Then we need to announce it in new work because, like, there's other SDOs involved. So like I see Dorothy here, or at least I saw her here. So like it gets announced to the other bodies we work with. Like for example, IEEE gets to see that we are rechartering and so on, right? So that will like probably take another month. So like before the next IETF, we should probably have a new charter if like there's agreement in the working group what needs to happen.
So anything
Okay, thanks. Okay,
So that's the surprise.
so yes, and because we have 5 more minutes, and we decided that we don't want to let you go before you see this, just a couple of thoughts on on the charter item, the future charter item about the document, like the model of the SHIC context and the SHIC profile. These are just a couple of thoughts that come from the discussions and try to summarize what is there and what needs to get done by the group in the following months. And basically, what we also identified with Pascal is that all the technology group documents are waiting for this to advance. So what we have here is, until now, we'll be talking quite a lot about SHIC context. The SHIC context is, we may say, the set of rules that are there. So we can have the rules and that are, each rule can be either a compression or fragmentation rule. And then you have in the specific rule, you have the behavior. Okay, how does the compression happens for that rule, or how does the fragmentation happen for that rule? And since some time, we identified that there is some other thing that could actually affect the way it's working. So we can call it SHIC endpoint metadata or SHIC endpoint. It's not the profile. Or SHIC endpoint. Some information additional about things about the device. Typically, for a LoRa device, that will be, is it a class A, class B, class C, or other things that actually will help you work with that, interoperate with that device. And what we say is that those things here constitute the SHIC profile. So the profile is the rules, so that you know what happened there, and some more information that allows you to actually go a step further and really have interoperability. So one point was that until we did all the work and all the hackathons and all the interrupts, until now we were pretty. We had a pretty good idea what we wanted to put here, but then how does it look exactly? It was an open question. Right now, I get the impression that people start to understand pretty well what needs to get there, and this comes from all the work that has been done at the hackathon and in implementations. So we'll have like the SHIC profile that has a SHIC context section and a SHIC endpoint metadata section, and there you have all the parameters that go here and here. So this is work that needs to get done, and one possibility is, of course, to use Yang as a modeling language to model this thing. I mean, we cannot just put a JSON file there, and we could, but that would be not that structured, and the IETF way of doing it would be to have a Yang model that defines the structure, and then we can just attack it with the different protocols. And then, of course, this gets into how these different sections can be formulated. With one big Yang file for the profile, and then we have sub Yang files for the different, like for the context and for the metadata. And then you can ideally will have a very common point here between the different L2 technologies. So that would be really, really great. This way, a generic SHIC endpoint, so for example, the network, can fetch from somewhere or can have the profile and can work transparently with any device from any technology. And that could be a really powerful thing. And yes, once we have that, then we have the serialization. That is there. We have RFCs, we have drafts. How this profile is actually going to get serialized in JSON, CBOR, or XML of your choice, and you can then attack it with different protocols like netconf, resconf, or callconf in a constrained manner. And so what we need to get this document out is agree on the structure, and I think that we're already there. So it's really starting with what's happening at the hackathons and what's happening with the reading code. Formalize it a little bit. So we already have done some work on the Yang model. So there are things out there, but I think that it might require some minor modifications so that it actually fits what is getting used. Then we go and see the Yang doctors just to make sure that the thing makes sense. And I think that could be a pretty tight work and pretty soon rapidly finished after we have the last call end of the SHIC IPUDP and we have the running code. So that work can be done in a very, very tight and nice schedule. If when the group decides, okay, now we put a little bit more effort on that. So these are a couple of thoughts, and I think that we're almost there, and a lot of drafts are actually waiting for that. Thanks.
Okay, that's pretty much it for this working group. So do we have any other business? Okay, so we thank you a lot again for all the work that's been done, and wish you a good continuation at the IETF this week and IEEE next week.
Thanks. And please do sign the blue sheets if you have not done so. Thank you very much.